Okay, some more sample problems for Chem 111. This one includes molarity calculations and dilutions. So, start with, if we have 0.150 molar sodium chloride solution is referred to as a physiological saline solution because it has the same concentration of salts as normal human blood. Calculate the mass of solute needed to prepare 275.0 milliliters of a physiological saline solution. Right? So, when we talk about this capital M, NaCl, right, we can say that the concentration, or that compound in brackets, is equal to this capital M, which is equal to moles of solute, in this case NaCl, versus the liters of the entire solution. Right? So if we have a concentration and a volume, that is going to allow us, because of this definition, to calculate the number of moles. We want a mass, so we're going to go from the volume times the concentration to give us moles, and then from moles we're going to go to grams. So, excuse me. We have this volume, 275.0 milliliters. The definition of this molarity is moles per liter, so we need our volume to be in liters. So we're going to convert from milliliters to liters. So 1 milliliter is 1 times 10 to the negative 3 liters. Same conversion we've been dealing with all semester. And then this concentration, we get 1.150 moles of sodium chloride for every 1 liter of this solution. Right? So that's going to cancel with that. So now we're going to left with moles of sodium chloride. And for every 1 mole of sodium chloride, we have a mass of 58.44 grams. So in this 275 milliliter solution, if we want it to be 0.150 molar of sodium chloride, we have to add 2.41 grams of sodium chloride. Let's look at another one. Lithium hydroxide is used in alkaline batteries. Calculate the molarity of a solution prepared by dissolving 1.495 moles of lithium hydroxide in enough water to give a final volume of 750 milliliters. Again, now we're just working directly from our definition of molarity, which again is molarity is the moles of the solute, in this case lithium hydroxide, divided by the liters of this solution, or the volume of the solution in liters. So we are going to then calculate this volume, convert this volume from milliliters to liters. 750 milliliters. Convert that to liters. So 1 milliliter is 1 times 10 to the negative 3 liters, which is going to give us a volume of 0.750 liters. We want a concentration, a molarity, so we're going to take the number of moles we have, 1.495 moles of lithium hydroxide, divided by this volume in liters, to give us a concentration of 1.99 molar lithium hydroxide. Right? Again, we have 3 significant digits here because this has 3 significant digits, which means this has 3 significant digits as opposed to the 4 in that value. All right, another one. Hydrochloric acid is widely used as a laboratory reagent in refining ore for the production of tin and thallium. and as a catalyst in organic reactions. Calculate the number of moles of HCl in 62.85 milliliters of a 0.453 molar HCl solution. Again, molar is going to be the moles of solute, in this case HCl, per liter of solution. So if we want the number of moles, we're going to have to figure out the volume, multiply this by a volume in liters. So we're going to take 62.85 milliliters of the solution. 1 milliliter is 1 times 10 to the negative 3 liters. And then now we want to get rid of liters, so we get, for every 1 liter of the solution, we're going to get 0.453 moles of HCl. So in this, we're going to end up with, if we take the volume, convert to liters, multiply there, we get the number of moles of HCl, which would be 0.02847 moles of HCl. But again, we have to look at significant digits. We have 4 here, 3 there. Our final answer should have 3 significant digits. So we're going to get 0.0285 moles of HCl. Calcium chloride is used to melt ice and snow on the roads and sidewalks and to remove water from organic liquids. Calculate the molarity of a solution prepared by diluting 165 milliliters of 0.688 molar sodium chloride to 925 milliliters. Right? In this question, they use the term dilution, right? Which means that we can use the dilution equation, which is the concentration of one solution times its volume is equal to the concentration of that solution under the second conditions times its volume. We want to solve for the concentration of this new solution, or M2. So M2 is equal to M1 V1 over V2. Now, we're going to, this is the molarity, remember, is moles per liter. So we can do this by converting that to liters, and I'm going to do all of this in one step. So we're going to take the 165 milliliters of the first solution, V1, convert it to liters, and then multiply by, so this whole thing here is V1, multiply it by M1, the 0.688 molar. Right, so though that whole thing is this top, and then we're going to divide by this whole thing in the new volume V2, but again we're going to convert it to liters, 925.0 milliliters. Convert from milliliters to liters, and we end up with 0.123 molar. So we're going to take all of this, divide by all of this. If we look at this, we have 1 times 10 to the negative 3 on the top and 1 times 10 to the negative 3 on the bottom, which is going to cancel out. So we can actually do this calculation as well using just the milliliters. 165 milliliters times the concentration divided by 925.0 milliliters gives us this same value. Right? So whichever way we do this, we get this diluted concentration of 0.123 molar CaCl2. Right? This is one of the only times where we don't necessarily have to convert our units. Because we had to convert both of them, that's going to cancel out. But you can still do it either way. You'll get the acceptable answer, whichever way you choose to do it. Right? So what volume in liters of a 10 molar HCl solution is needed to make 2 liters of 2 molar HCl solution by dilution with water? Again, this equation is saying the word dilution, so we can use M1 V1 equals M2 V2. Right? We have, this is our M1, this is M2, so M1 is 10.0 molar, M2 is 2.00 molar, and V2, this is what we want at the end, is 2.00 liters. So we want to solve this equation, or rearrange this equation for V1. So V1 is equal to M2 V2 over M1, which is equal to 2.00 molar times 2.00 liters divided by 10.0 molar, which gives us 0.400 liters. So it's going to take 0.400 liters of water, or of this 10 molar solution, to make 2 liters of 2 molar solution. How many milliliters of concentrated nitric acid, which has a concentration of 16 molar, should be diluted with water in order to make 2 liters of a 2 molar solution? Again, we use the term diluted, so we're going to use M1 V1 equals M2 V2. We want a milliliters of this concentration, so that we want to solve again for V1. V1 is equal to M2 V2 over M1, which is going to be equal to this is M1, this is M2 V2, so this is going to equal 2.00 molar times 2.00 liters divided by our initial concentration of 16. We're left with liters. That's going to give us a value of 0.250 liters. We want a concentration in milliliters, so then we have to convert this. That 1 times 10 to the negative 3 liters gives us 1 milliliter, to give us a final volume of 250 milliliters, or 2.50 times 10 to the second milliliters. Either way. Right. 3 significant digits, we can either use the decimal or, more appropriately, scientific notation. Right. How many moles of ions are released when 0.27 moles of cobalt-2 chloride is dissolved in water? So this is sort of a question that goes back a little bit in time, not necessarily calculating concentration. But when we put this in water, COCl2, it's going to break apart into its 2 ions. Right? This is an ionic compound. It's going to be completely soluble, so we're going to end up with CO2 plus aqueous plus 2Cl minus aqueous. Right? So if we look at the total number of ions in solution, for every 1 mole of this we react, we are going to produce 3 moles of ions. Right? So if we have 0.27 moles of COCl2, for every 1 mole from this equation, for every 1 mole of COCl2, we get 3 moles of ions. right? 1 mole of CO2 plus and 2 moles of Cl minus, which is going to equal, again, we have two significant digits, so 0.81 moles.